Way back in Chapter 9, we learned about 5 different types of reactions: synthesis, decomposition, single replacement, double replacement, and combustion. Several of those reactions involve the transfer of electrons, including combustion. I put this reaction up on the board because it was the one I was doing just earlier. Burning magnesium and oxygen to produce magnesium oxide. You can see it's quite a bright reaction, isn't it? So you can see we have 2 magnesium atoms with no charge at all, 0 charge. But during the process of the reaction, each of these magnesium atoms will give up 2 electrons to these oxygen atoms, where up until now the oxygen atoms had 0 charge as well. But in the process of the reaction, they accept those electrons, and in doing so we form ions that form the compound magnesium oxide. So with 2 magnesium atoms and a single oxygen molecule, we get 2 formula units of magnesium oxide, where magnesium has a +2 charge and oxide has a -2 charge. We see this example of electrons being transferred in this process. So any reaction that involves the transfer of electrons like this, we call an oxidation-reduction reaction, or redox for short. In case you're wondering, it's not as easy to say ox-read, so we say redox instead. Now let's explain these terms for just a moment. Oxidation involves the loss of electrons. In this reaction, magnesium lost electrons. Magnesium was oxidized in the process. A reduction involves a gain of electrons. In our reaction over here, the oxygen gained electrons. Oxygen was reduced in the process. Another way of looking at this is that the magnesium atom undergoes oxidation, and in the process, electrons are one of the products of this reaction. So the magnesium oxidation yields a magnesium ion and 2 electrons. Meanwhile, for the reduction process, oxygen gains 2 electrons, thus the electrons are a reactant. So oxygen with 0 charge plus 2 electrons yields the oxide ion with a -2 charge. Now here's a good way of remembering which is which. A mnemonic that I like to call Leo says Gur. If you lose electrons, that's oxidation. If you gain electrons, that's reduction. Leo says Gur. What we also notice in an oxidation-reduction reaction is a change in oxidation numbers for the elements involved. For instance, magnesium starts out as a neutral atom, an oxidation number of 0. But after the oxidation, we see that magnesium becomes +2. Losing electrons means it has changed its oxidation number from 0 to +2. Oxygen begins as a 0 charge as well, but it gains these 2 electrons, changing its oxidation number to -2. So in these reactions, we always look for changes in oxidation number, and that will help us to know what's being oxidized and what's being reduced. So we already know that in this relationship, one element is oxidized and the other's reduced. But there's another aspect, another view you might take of this relationship, and that is this. The item that's being oxidized is in the process reducing the other element, or causing the other element to be reduced. Likewise, this element, while being reduced, is causing this other element to be oxidized. Therefore, we would say that magnesium is the reducing agent. It causes the oxygen to be reduced. And then oxygen is the oxidizing agent. It causes the magnesium to be oxidized. Think of it this way. Let's say that electrons are like money. And as a matter of fact, in the chemical world, it is kind of like that. Electrons are the currency of chemistry. So if I'm losing money, that means I'm being oxidized. But the guy that's getting my money, he's the oxidizing agent. He's taking my money, thus helping me to be oxidized. Meanwhile, he's receiving the money, he's receiving the electrons, so he's being reduced, but in the process, as long as I'm passing out money, I'm helping him to be reduced, aren't I? So therefore, I'm the reducing agent. Here are a few guidelines to help you determine oxidation numbers of elements and compounds. First of all, if it's an uncombined element, like sodium by itself, or oxygen molecule by itself, or hydrogen molecule by itself, that is going to be a 0. The oxidation number is 0. If you have hydrogen that's involved in a compound, normally speaking, that hydrogen is going to be +1. It's going to have +1 as its oxidation number. The only time that it doesn't is when it's in a metal hydride like sodium hydride, then it's -1. But for the most part, you're going to see hydrogen as a +1. Fluorine, the king of all electronegative elements, if it's in a compound, is going to be -1. When oxygen's in a compound, it's usually -2. The only time it's not is when you have a peroxide situation, like hydrogen peroxide. In that case, oxygen is -1. But again, for the most part, you're going to find that oxygen is a -2. If you have a monatomic ion, those are their usual charge, like bromine would be a -1, or calcium would be a -2. So if you have an ion sitting by itself, it's going to have the charge that it normally would. And one more, the oxidation numbers of group 1 metals, group 2 metals, and aluminum match their usual charge. So for group 1 metals, that would be +1. Group 2 metals, that would be +2, and for aluminum, that would be +3. So let's see if we can use these guidelines for a couple of examples. Using the guidelines we just discussed, let's try to find the oxidation number of phosphorus in aluminum phosphate. So we said before that oxygen is normally a -2. It's not a peroxide situation, so oxygen will be a -2. There's 4 of them, so 4 times 2 is -8. So far so good? Okay. Now what we say about aluminum, along with group 1 and group 2 metals, it's their normal charge. So aluminum is a +3. Now phosphorus is going to be the opposite of the combination of these two numbers. In other words, +3 and -8 is -5. So phosphorus will be +5. And that's how you do it. In this case, phosphorus has an oxidation number of +5. Let's do another one. Find the oxidation number of nitrogen in N2H4. So first off, we know that hydrogen here is not in a metal hydride. So it's going to be +1. But since there's 4 of them, that's 4 times +1, so we have +4. Get it? Okay. Now that means that the combined amount of nitrogen has to be opposite of that, or -4. But that's for 2 nitrogens, right? So to get each nitrogen, I simply divide this by 2, and that means that nitrogen has an oxidation number of -2. You get it? Oh, tricky. What about ion groups? Just do the same thing you've been doing before and take into account the electrons that are extra, like this. First of all, oxygen is going to be a -2. This isn't a peroxide situation, so oxygen is -2. There's 4 of them. That means we have a total of -8. Now, since there's only 1 arsenic, we would think, okay, +8. However, we have a net of a -3 situation for the entire ion group. So it's not +8, we have 3 less than that. It's +5. So 5 and -8 give me -3. So everything should add up to be 0 if it's a neutral group, but if it's an ion group like this, it should add up to be the charge on that ion group. 5 and -8 equals -3. Okay? How about you try a couple? All right, here's your assignment. I have 2 compounds here. We have sodium perchlorate and the chromate ion. I want you to try to find chlorine in sodium perchlorate and chromium in the chromate ion. So find the oxidation numbers of those two in these two compounds. You got this. So that's all we're doing for today. Remember, we talked about oxidation and reduction reactions, how oxidation is a process in which you're losing electrons. Reduction is a process in which electrons are being gained. Leo says grr, right? We also said that whatever's being oxidized in that reaction is causing the reduction of something else in the process. So whatever's oxidized is the reduction agent. And likewise, whatever's being reduced is the oxidizing agent because it's causing something else to be oxidized in the process. During oxidation, electrons are a product, and in reduction, electrons are a reactant. Then to help us with determining oxidation numbers, we set forth some guidelines that should help us in the future to determine what those oxidation numbers are. As always, I hope that this was helpful to you. I hope it's informative. If I can help you in any way, just please let me know. Give me an email and I'll be glad to help. Guys, until next time, God bless.